Look at that light. It has been traveling for 13 billion years. It has seen the birth of galaxies and the death of stars. It is moving right now at 186,000 miles per second. And here is the question that keeps astrophysicists awake at night. Where is it going? Where is everything going? Not just the light, not just the planets, but the galaxies, the black holes, the dark matter, the atoms that make up your chair, your lungs, the coffee cooling on your desk. Where is the final destination of all things? For 5,000 years, we thought the universe was a stage, static, eternal, a permanent theater for human drama. We were wrong. In 2025, we have finally mapped the currents. We have read the fine print of gravity. And the truth is terrifyingly simple. Everything is falling. To understand where we are going, you first have to admit you don't know where you are. Stand outside tonight. Look at the stars. You feel stationary. You feel safe. You are lying to yourself. Right now, planet Earth is spinning at 1,600 kilometers per hour. We are orbiting the sun at 107,000 kilometers per hour. The sun is dragging us around the Milky Way at 720,000 kilometers per hour. And the Milky Way? The entire galaxy, with its 400 billion stars, is screaming through intergalactic space at 2.1 million kilometers per hour. But relative to what? Relative to the cosmic microwave background, the leftover glow of the Big Bang. That is our true speedometer. But here is the discovery of 2024 that rewrote the textbooks. Speed isn't the story. Direction is. For decades, we noticed a strange anomaly. The Milky Way, the Andromeda Galaxy, and 50 other galaxies are all drifting toward the same patch of empty sky in the constellation Centaurus. We called it the Great Attractor. We thought it was a supercluster. We were wrong again. The Great Attractor is a gravitational anomaly, a basin of attraction the size of 1 billion suns. But even it is just a ripple. In 2025, the James Webb Space Telescope and the Euclid Dark Matter Mapper confirmed that our entire supercluster, Laniakea, which means immeasurable heaven, is being pulled towards something else, something we cannot see. We call it the dipole repeller. Half of the sky is pushing us, the other half is pulling us, and the net result is that we are falling toward a region of space that contains almost nothing. A void. A cosmic desert. Think of a river. You think the water flows downhill. But what if the hill is actually a hole? We are not flowing toward more matter. We are flowing toward less matter. Because in cosmology, emptiness is a vacuum cleaner. The universe hates a vacuum, so everything is sliding into the voids, like marbles rolling into the cracks of a wooden floor. So, local answer? We are going toward the Shapley supercluster, then the Vela supercluster, then the Great Nothing. But that is just the local flow. That is just traffic on the highway. We need to look at the highway itself. In 1929, Edwin Hubble discovered the universe is not static. It is expanding. Like bread in an oven. Every galaxy is moving away from every other galaxy. But wait, if everything is moving apart, how can we also be falling toward the Great Attractor? Because gravity is weak, and dark energy is strong. Let me explain. Gravity is the local bully. It rules the neighborhood. It keeps your feet on the floor and the moon in orbit. It pulls Andromeda toward us. But dark energy? Dark energy is the global landlord. It owns the entire building, and it has decided that the rent is going up. For the first 8 billion years after the Big Bang, gravity was winning. The expansion was slowing down. We expected a big crunch, a reversal, a collapse back into a singularity. Then, 5 billion years ago, something flipped the switch. Dark energy, a force we still do not understand, overpowered gravity. The expansion didn't just resume, it accelerated. Galaxies that were moving apart began sprinting. Today, the Hubble constant, the rate of expansion, is a subject of a violent war in physics. The late universe says it's 73 kilometers per second per megaparsec. The early universe says 67. This discrepancy is called the Hubble tension, and it means one of two things. Either our measurements are wrong, or the laws of physics are broken. Here is the brutal truth of 2025. Most of the universe is already gone. Not destroyed, just out of reach. Because the expansion is accelerating faster than the speed of light. No, that's not a violation of relativity. Space itself is stretching. Galaxies beyond a certain distance, roughly 18 billion light years, are moving away from us faster than the light they emit can ever travel back. Those galaxies have crossed the cosmic event horizon. We can see them now as ghosts, but their light is the last message we will ever receive. In a few trillion years, an astronomer in the Milky Way will look up and see nothing but blackness. No Andromeda, no Virgo cluster, no stars at all. Just the faint glow of our own dead galaxy. That horizon is not a wall. It is a speed limit. The universe is expanding so fast that 97% of the galaxies we can currently see are already causally disconnected from us. We are watching a replay. The game ended billions of years ago. But that's just the expansion. What about the matter that stays inside our local group? Let's fast forward. Not millions of years, not billions. Let's go to 10 to the 40 years from now. That is a 1 with 40 zeros after it. In 2025, the Super Kamiokande Neutrino Observatory in Japan placed the most stringent limits on proton decay yet. A proton, the stuff of every atom in your body, might not be eternal. Current data suggests the half-life of a proton is at least 10 to the 34 years. That's a very long time. But if the proton decays, then matter itself is mortal. Welcome to the degenerate era. The stars have all died. The last red dwarf, a star the size of Jupiter that burns for 12 trillion years, has finally flickered out. The universe is dark. But it is not empty. What remains are stellar corpses, white dwarfs made of crystallized carbon, diamond planets, literally, neutron stars denser than an atomic nucleus, and black holes. These objects no longer fuse atoms. They just sit, cold, silent. But even solid matter is not permanent. Quantum mechanics has a cruel joke: tunneling. Over incomprehensible timescales, the atoms in a white dwarf will quantum tunnel into iron. Then the iron will tunnel into a neutron star. Then the neutron star will tunnel into a black hole. Eventually, every piece of normal matter in the universe, every rock, every frozen corpse of a star, will collapse into a black hole. We enter the black hole era. It lasts from 10 to the 40th to 10 to the 100 years. For 60 orders of magnitude, the universe is nothing but black holes drifting through infinite darkness. No light, no heat, no chemistry. Just gravitational singularities orbiting each other in a slow funeral waltz. This is where everything is going, into the dark hearts of dead stars. But even black holes are not forever. In 1974, Stephen Hawking realized something that upset Einstein. Black holes are not black. They glow. It's called Hawking radiation. Quantum mechanics says that empty space is actually fizzing with virtual particles. Normally, they pop into existence and annihilate instantly. But at the edge of a black hole, the event horizon, one particle falls in and the other escapes. That escaping particle is radiation. And where does the energy for that radiation come from? It comes from the black hole's mass. Black holes are evaporating. The physics is insane. The smaller the black hole, the hotter it burns. A supermassive black hole, like Sagittarius A star at the center of the Milky Way, has a temperature of 1/10,000,000th of a degree above absolute zero. It will take 10 to the 100 years to evaporate. That is the ultimate timescale. 10 to the 100th power, a googol, more years than there are particles in the known universe. But eventually, the last black hole will emit its last photon. It will shrink to the Planck length, and then it explodes. Not with the fury of a supernova, but with the exhaustion of a candle burning its last wick. One final flash of gamma rays, and then the black hole is gone. What is left? Nothing. Not empty space. Nothingness. Because even space itself, the vacuum, is not stable. We have arrived at the destination. The final answer to the question, where is everything going? It is going to heat death, also known as the Big Freeze. Imagine a cup of coffee, hot at one end, cold at the other. You stir it. The heat spreads out. Eventually, the entire cup is room temperature. No more stirring, no more work, no more life. The universe is that cup. In 2025, the Wilkinson microwave manisotropy probe data confirms with 99.997% certainty that the geometry of the universe is flat. That means it will expand forever. No big crunch, no big bounce. Dark energy wins. As the last black holes evaporate, the universe becomes a thin soup of photons, neutrinos, and electrons. These particles are so far apart, light years between them, that they will never interact again. The temperature of the cosmos drops to 10 to the negative 30 Kelvin, a fraction of a degree above absolute zero. This is the equilibrium state, maximum entropy. There is no more where, because there is no space to move through. There is no when, because there is no change to measure time against. Everything that was ever built, every star, every poem, every war, every kiss, every discovery, has been diluted into a uniform mist of radiation. But here is the twist, the true story, the one they don't put in the textbooks. We said, where is everything going? The answer is not a place. It is a state. The universe is going to sleep. There is a disturbing footnote to this story. It's called the Boltzmann brain paradox. In a universe that has reached maximum entropy, random quantum fluctuations will occasionally, over timescales of 10 to the 10 to the 50 years, assemble a brief conscious entity. A brain that thinks, I am, and then dissolves back into nothing. If that is true, then statistically, you are probably not a real human living in 2025. You are far more likely to be a Boltzmann brain, hallucinating a universe, about to disappear. That is the nightmare of modern cosmology. But I don't believe that, because we have evidence. We have the cosmic microwave background. We have the Hubble deep field. We have the fingerprints of the Big Bang. Where is everything going? Into the long, dark night of the heat death. But night implies a morning. Eternal inflation theory, tested in 2024 by Bicep3 data, suggests that our universe is just one bubble in a frothing sea of multiverses. Our bubble may die, but new bubbles are constantly nucleating. Every black hole evaporation is, in some theories, the birth of a new baby universe on the other side of the singularity. So where is everything going? The atoms in your body, the oxygen, the carbon, the iron, were forged in a star that exploded 5 billion years ago. Those atoms have been to the edge of the galaxy and back. They will fall into a black hole. They will evaporate as radiation. And that radiation, in a trillion years, might seed a new Big Bang.
You are not a thing. You are a temporary pattern in the flow of energy. You are a whirlpool in the river. The river is not going anywhere. The river is the going. The universe is not heading toward a place. It is heading toward a process. The process of cooling, of slowing, of forgetting. But here is the final truth. You get to be conscious for the brief moment when the universe is still hot, still complex, still interesting. The question is not where is everything going? The question is, while you are here, what will you do with the light? This has been Where is Everything in the Universe Going? The True Story, 2025.